Welcome to our next video, and the topic here is multiplying and dividing rational expressions. If you were here for our last lesson on adding and subtracting rational expressions, you would have heard me say how I actually think multiplying and dividing is a little bit easier. I also would classify it as a little bit more fun because you can do a lot of canceling. And if you understand how factors work, and you understand how to cross-cancel, then you might agree with me that multiplying and dividing is easier and also a little bit more fun than adding and subtracting rational expressions. It's also easier in the manner that I don't need a common denominator, which is so nice because that can be the trickiest part to adding and subtracting sometimes. And so when you have something like this, of which I can't cancel anything, these x's are both on the same side of the fraction bar. They're both in the numerator, so I can't cancel them. They'll actually end up combining and increasing in size. The 2 doesn't evenly go into 5, neither does the 3. And so I can't cancel anything, and so you simply multiply across. 2 times 3 is 6, and x times 5x is 5x squared. Again, can't simplify anything? That would be my final answer. So if you like multiplying and dividing rational expressions might be your thing. Now let's look at number 2. Number 2, I'm going to show you 2 ways. One way, the way I prefer, and that's a lot of canceling. I'd rather cancel things right now and do less work in the long run rather than do all my work and cancel afterwards. So I'm going to show you the quick way first. And I'll even label it as the quick way. And all I'm going to do, so I'm going to rewrite it so that when I start to cancel things, I'm not canceling them from our original problem. But when I do this, I'm going to start to cancel some things. I know that x times x is x squared. I also know that if I had an x and I was dividing by x squared, this x would end up moving to the bottom. So I'm going to cancel that out. Now let me grab another color so you can really see this. This x and this x, there's 2 x's in the top, also known as x squared, and I have an x squared in the denominator, so factors in the numerator can cancel with factors in the denominator. Essentially all of my x's canceled out. And now I'm just multiplying numbers. 2 times 5, well that's 10, and 3 times 9 is 27, and so my final answer is 10 over 27. What I like to call long way, and it's not necessarily that much longer in this specific example, but you multiply across and then cancel. So 2x times 5x is 10x squared, and then 3 times 9x squared is a 27x squared, and now I need to cancel yet. So looking at these, and perhaps this is a little bit easier for you to see what cancels, the x squareds, same in the numerator as in the denominator, and their factors. That's a really important part here. Their factors, common factors, can be canceled out, and so that reduces to 10 over 27, which is the same thing I got the other way. Alright, I'm going to draw this little divider so that we don't get confused with number 3 over here. Number 3, we're dividing. And believe it or not, dividing is not that much more difficult because you can use a trick that you guys have known for a long time now. When you divide a fraction, it's the same thing as multiplying by the reciprocal. And the reciprocal essentially means I'm going to flip-flop these. The numerator is going to become my denominator, and my denominator is going to become my numerator. And then I can multiply across. Again, I'm going to use the quick way here. I think it's a little bit easier. You might disagree, and so you can pause the video and do it your way, and then play the video and double check your answer. But I like to cancel. I also like to see things disappear. This x is going to cancel with this x. And 3 can go into 9 3 times. And now I don't have anything left, so I'm going to multiply across. 2 times 3 is a 6x squared. And the 5's got nothing to multiply with, so the 5 stays there by itself, and I cannot reduce that fraction any further. So my final answer would be 6x squared all over 5. One last example with this, a little bit more difficult. And so that's why it has its entire paper to itself. You can see already a lot going on. But the first thing I would do, and you should start doing the same, is when I see I'm dividing, the first thing I'm going to do is I'm going to rewrite this, but instead of dividing rational expressions, I'm now going to choose to multiply them. This is one of those examples that maybe you haven't agreed with me so far. I think these are a little bit more fun. You get to see a lot of things start to cancel. Now, the first thing I would recommend after doing that is let's not cancel these x's. I can't do that. This x belongs to the 4x monomial term that is part of a trinomial in the bottom here. You cannot cancel common terms. Even though there's an x here and there's an x here, I can't do that. Same thing over here. Even though there's an x in the denominator and x in the numerator, they're not common factors. They are common terms, and I can't cancel common terms. So what I would want to do is any quantity, anything more than one term, I'm going to put in parentheses unless I know I can factor it. Hopefully this you should be recognizing as something you can factor. This is one of those that we ended up learning the shortcut that I would look for factors of 4 that add to give me 4. The factors of 4 that add to give me 4, you're probably screaming this in your head already. You know what that is. That would be an x plus 2 and another x plus 2. So I'm going to rewrite that in factored form. And now I'm going to cancel any common factors. So this again, here's maybe where you'll finally agree with me. I think this is the fun part. Cancel this, cancel that. They're the same factor. X plus 2, that quantity is the same as this quantity. X minus 3 is the same as x minus 3, so let's get rid of those. That means I have nothing left in my numerator. I got to represent it with something, so I'm going to put a 1 there. I have a 5 and an x plus 2, and so that's all that would be left over. And so that problem that looked really difficult wasn't that bad after all, if you remember how to factor.